We're moving on from the perimeter of a circle, and the perimeter, because the circle is a special shape, the perimeter of a circle has a special name, and it starts with a C. Circumference. Very good. We had circumference before, and when we were looking at circumference, we learned that if you know in a circle, that's not bad. If you know the measurement from the center of the circle, if you go from the center to anywhere on the circumference, right? Anywhere you like. We call that, of course, starts with our
Radius.
the radius. Very good. The radius is the same, whichever direction you're pointing. It could be pointing down, up, left, right, anywhere. Question. Okay, so I think if I have it on the board, it would be great to have in your book as well. Okay? And you have drawn a few circles, so you can make a start on it. Now we remember, right, that if you know what the radius is, then you can say the circumference will be equal to that radius times a special number. What was the special number? Yeah, Nathan. Yes, say it again. Okay, we're going to have a 2 in there. There's another number I need, as well as the 2, Adam. Pi, which is about 3.14159, yeah, and so on. It never stops. If you remember back to way back earlier in the year, when we were looking at surds, fantastic. We said that surds were irrational numbers, right? They go on forever and ever and ever and ever, right?
Repeat.
And they never repeat. Well, pi is even more special. It's not even a surd. Okay, it's even more crazy than a surd if such a thing was possible. Okay, and just like a surd, it never repeats. It goes on forever. Okay, so we take 2 and pi, and then we multiply by the radius, and that'll give you circumference, that whole length around the edges. Okay, so we established that, and we're going to use that fact today as we think about area. Perimeter to area, length to area, it's a very natural progression. So here we go, we've got some circles. How are we going to work out the area of these shapes? They're weird, they're curvy and round, right? So it doesn't quite follow the rules that we use with our other shapes. You want to give a suggestion?
Don't you find this, so you get the center, so you rule into the center and you find like the radius, and then you've got to times the radius by pi, and like you can do that twice, because if you cut down the middle you can do like that.
Okay, all right. So what we're getting towards, what you're leaning towards, and we're going to establish is just like a formula for circumference. We will establish a formula for area, but hold on to your hats. I'm going to show you how it is that mathematicians have done this ingenious thing, and we've got a few steps here to work out what this formula is. There's a few different ways, but I'm going to show you one of my most favorite ones. Okay. So here we go. You've got your circles, right? You've got your circles. Now, I've done mine in colors because this will make it more obvious. If you don't have any colors on you, if you maybe have like a blue pen and a red pen, that'll do, as long as you can distinguish what's going on. Okay. Now, what I'm going to do, and I'm going to do this 3 times in sort of different ways. I've got this circle, and so far, I have it in 2 halves. Okay. Now this is a crucial step. Do you remember earlier in the topic we were looking at composite shapes? What's a composite shape? Yeah, Nathan.
The shape made up of more than one.
Very good. Yeah, it's a shape that's made up of more than one shape. So, for example, this L block, right? We don't have a formula. We have a formula for squares, and a formula for rectangles. Thank you, and a formula for all kinds of shapes. We don't have a formula for L's, but that's okay. That's okay. What did we do to this thing in order to work it out? Yeah, Ethan.
You put like a dotted line down, but you have to kind of do it diagonally because yours isn't.
Okay, yeah, mine's not a very good L, is it?
It's
Okay.
supposed to be straight.
Yeah, that's right. Okay. So, in other words, we're dividing up a shape that we don't have a formula for, into pieces that we do have formulas for, and that's exactly what we're going to do here. So, here's the way I'm going to begin. I've got 2 halves at the moment. Okay. So it's like, okay, this bit and this bit. That's better, right? I've broken down the problem a little bit, but I can go a little further. I'm going to take each of these halves and divide them in half as well. So now I have quarters. Okay, I have quarters. So now, if I take each of these quarters, I can rearrange them a little bit. Okay, I'm going to rearrange them in a certain way, and we're going to draw these underneath. Okay, so we've got a few steps coming out of our circle. because they're quarters, by the way, because they're quarters, these have special names, these quarters when you're in a circle. Does anyone know it starts with a Q as well? 10-9? Quadrants, very good. So we have quadrants here. I'm going to take each one of my 4 quadrants and I'm going to reassemble them, right? I'm going to reassemble them so that they fit together like this. Okay, now maybe your brain is weirding out a little bit when you see that. You're like, what? How does that work? So let me try and help you because I have these colors for a reason. This I hope makes it a little more obvious.
Yeah.
Okay, so let me get some blue tack. Let me show you. What I've done is I've taken the orange half, I've taken the black half, I've divided them up, and then which way? This way? Right. The 4 quadrant, it's the same area. It's exactly the same area, but I've rearranged it. Okay.